Hi, welcome to section 1.3 where we're going to talk about weight and capacity, and we're going to use both the metric and the standard systems today. So we're going to start out by using the metric system when we're talking about weight. And usually when we talk about the metric system and weight, we actually use the word mass instead. And our main unit is gram. So we've got kilogram, hectogram, decagram, a gram, a decigram, centigram, and a milligram. There's 1,000 milligrams in a gram, and there's 1,000 grams in a kilogram. To give you an idea of weight, a dollar bill is approximately equal to 1 gram. A nickel is approximately equal to 5 grams. And if you had a liter of water, it's equal to approximately 1 kilogram, which is approximately 2.2 pounds. So that just kind of gives you an idea of their sizes. So let's go through some teacher solutions and our first example. So we have the total weight of a bottle of cooking oil and 2 bags of sugar is 7 kilograms 50 grams. If the weight of each bag of sugar is 1 kilogram 800 grams, find the weight of the bottle of cooking oil. So in other words, we've got a total weight here. So we're at total. And I'm going to put down the sugar because we know that. We don't know the oil. So I'll just write down sugar for a second. They tell us the total is 7 kilograms 50 grams, and they tell us that we have 2 bags of sugar. That's 1 kilogram 800 grams. And what we're looking for is we're looking for the oil, so we're looking for this little piece right here. So at the end of the day, it's going to be a subtraction problem, but before we can even do that, we got to figure out how much sugar we have. So we've got 1 kilogram 800 grams, so 1 kilogram 800 grams. And you can take it times 2, or you can just add it twice, which I'm going to add it twice. So that's 2 kilograms 1,600 grams. But remember that 1,000, there's 1,000 grams in 1 kilogram. So in other words, this 1,000 grams is another kilogram, so we are left with 3 kilograms 600 grams. So that's this total part right here. And now we just have a subtraction problem. So I'm going to start out with my 7 kilograms and 50 grams. And I'm going to subtract my 3 kilograms 600 grams. I'm going to do some borrowing. This becomes 6 kilograms, which I'm going to be borrowing 1,000 grams, so that becomes 1,050 grams because we got to add it together. And 1,050 subtract 600 is 450 grams, and 6 minus 3 is 3 kilograms. So that means that that oil weighs 3 kilograms 450 grams. Alright, so that's a teacher solution for that type of problem. I have another teacher solution where we have a pineapple that weighs 2 kilograms 50 grams. A watermelon is 600 grams heavier than the pineapple. What is the weight of the watermelon? So we will write pineapple, and we will have a watermelon. So my pineapple is 2 kilograms 50 grams. Now that watermelon is going to be heavier by 600 grams. Remember, this part is still this 2 kilograms 50 grams. So what we're doing is we're looking for our total weight. And when we look for our total weight, this becomes an addition problem. So we have 2 kilograms 50 grams, and we're going to add 600 grams to it. So we have 2 kilograms 650 grams is the weight of our watermelon. So that's our teacher solution for dealing with the metric system. Now what we're going to do is we're going to talk about weight in terms of the standard system. And so when we measure babies, we do this, and that's in pounds and ounces, and then we do have tons. And so my daughter, Elizabeth Grace, was born at 7 pounds 8 ounces. And so since we can see that 1 pound equals 16 ounces and 8 ounces is exactly half of that, she weighed exactly 7.5 pounds. Okay, so let's go through an example. Our first example is going to compare. So we have 6 pounds 15 ounces and we want to compare it to 115 ounces. And whenever you compare, you want to make everything the same unit. So what I'm going to do is I'm going to change that 6 pounds to ounces. And I know there's 16 ounces in a pound, so I just take 16 times 6. And I get 96 ounces. I still have that 15 ounces left over, so I still have another 15 ounces. So then that becomes 111 ounces. 111 is smaller than 115, so therefore I have a less than sign. Okay, so now what we want to do is we want to do a teacher solution, and we're going to talk about tomatoes, avocados, and squashes. So I have a tomato that weighs 3 ounces, so I'll put T for tomato. I'll just write it out. And we said that that's going to be equal to 3 ounces. Okay, next I have an avocado. That's an O, sorry. And they said that that's 4 ounces more. Alright, so I did my first sentence. A squash weighs twice as heavy as the avocado. So now I'm going to talk about a squash. Now it's going to be twice as big as the avocado. So if the avocado is this big, then we just want to double it. So the squash will be that big. Well, first of all, 3 ounces plus 4 ounces is 7 ounces. So this will be 7 ounces as well. So what is the weight of the squash? Well, the squash is 2 times 7. So we have 14 ounces. Since the 14 ounces is less than 16, we can leave it like that. We don't need to change it to pounds at all. Alright? So that was our teacher solution for weight. Now what we're going to do is we're going to go to capacity. Capacity deals with volume, really. And so with the metric system, a lot of people struggle with how big is a milliliter? Well, if I look right here, which I'm circling, I don't know how many of you are familiar with teaspoons, but a teaspoon is actually very, very close to 5 milliliters. And so if you ever give a kid medicine and it says for 1 teaspoon, it's actually 5 milliliters. Alright, so I got a teacher solution question for this one. So Jim bought 7 cans of paint. Each can contained 4 liters of paint. He had 3 liters, 400 milliliters of paint left. After painting his house, how much paint did he use? Alright, so first of all, we got to figure out how much he bought. So we're going to put bought right here. And we're going to use our first sentence, 7 cans of paint. Each can contained 4 liters of paint. So I am going to have 7 liters. 1, 2, 3, 4, 5, 6, 7. I meant 7 cans. So here's my 7 cans of paint. Each can of paint had 4 liters in it. So if I put 4 liters for each can, this becomes a multiplication problem. So we might as well just figure out how much he bought right away. And you simply take 4 times 7, and there is your 28 liters. Now what we got to do is they're telling us how much he had left. So he had 3 liters, 400 milliliters left. So put left right here. And so this amount right there is 3 liters, 400 milliliters. And so what we're looking for is how much did he use on his house? So this becomes a subtraction problem. So we take 28 liters and we're going to subtract 3 liters, 400 milliliters. We have to borrow, so this becomes 27 liters, and there's 1,000 milliliters in a liter. So this is 600 milliliters, and this is 24 liters. So that's how much he used on his house. Alright, so that's the metric system with capacity. Alright, now what we're going to do is we're going to talk about the standard system for capacity, and actually the standard system is very tricky for students, and the reason it is because it's hard to remember. It's hard to remember that there's 4 quarts in a gallon, 2 pints in a quart, 2 cups in a pint. So a lot of times what teachers do is they make the gallon man, and if you can see this picture right here, it simply shows 4 quarts in a gallon, 2 pints in a quart, 2 cups in a pint. It's really nice and handy for the students to have a visual. So we're going to first do a teacher solution problem, and then we're going to do a conversion problem. So example 1 is a teacher solution problem. Container A holds 17 gallons of water. Container B holds 8 gallons, 2 quarts less. How much does container B hold? So we have container A, and they told us that that holds 17 gallons. Then we have container B, which we don't know how much it holds, but we do know that it holds 8 gallons, 2 quarts less. So once again, it's a simple subtraction problem by looking at the picture. So I have 17 gallons, and I'm going to subtract 8 gallons, 2 quarts. Got to borrow from the gallons, so we got 16 gallons here. Now we got to get quarts, and I can see that there's 4 quarts to a gallon, so this becomes 4 quarts. 4 minus 2 is 2 quarts. 16 minus 8 is 8 gallons. So container B is 8 gallons, 2 quarts. Okay, last example is a conversion problem. So what we're going to do is I'm going to move this right here so we can see it better, because we're going to use it a lot. Alright, so in this example, Matt drinks 3 cups of juice daily. How many pints of juice does he drink in 2 weeks? How many quarts does he drink in 2 weeks? How many gallons does he drink in 2 weeks? So first of all, I want to figure out how many cups he drinks in 2 weeks. So basically we take 3 cups, and we're taking it times 14 because there's 14 days in 2 weeks. So he drinks 42 cups in 2 weeks. We're going to take that, and we're going to first change it to pints. Now we know that there are 2 cups to a pint, so we're going to start out with, and now make that 42 cups over 1, and now I'm going to write my new ratio of 2 cups, 1 pint. Remember, I want the cups on the bottom so that the cups cancel, and so I have 42, because top times the top, over 2, and there I have 21 pints is how much he drinks in 2 weeks. So now the next question asks, how many quarts does he drink? So I'm going to start out, and I don't need to go back to the 42 cups. I can just start with my 21 pints. So I've got 21 pints here. I'll put it over 1. And I know to get to quarts, I have 2 pints in 1 quart. So 2 pints, 1 quart. So that becomes 21 over 2. The pints cancel. This is a division problem, so we get 21 divided by 2, and so we have 1 left over, because that's a 0, because 2 doesn't go into 1. So what we could say is, this means that I've got 10 quarts up here, I have 1 pint left over. So we have 10 quarts, 1 pint left over. And now our last part of the problem is we want to go to gallons. So when I go to gallons, I'm going to not deal with the pints, I'm going to deal with the quarts. So I have 10 quarts over 1. And I know that there's 4 quarts to a gallon, so I'm going to have 1 gallon is equal to 4 quarts. That'll be my ratio. Top times the top, so I have 10 over 4. Once again, I have another division problem. So that's a 2 and that's an 8. So what this means is I have 2 gallons on the top, but I have 2 quarts left over. So I have 2 gallons, 2 quarts, Now don't forget we still have that pint that we didn't deal with yet. 1 pint. And that's how you do your conversion problem.